Okay, and then back to me. You should have my screen there now. So welcome everybody. Really great to see people here and joining in. I'm Andrew Marshall. I am the Kaiarahi for the network of experts down here in Waikato and Bay of Plenty. Previous to this, I was the curriculum leader at Rototuna Senior High. So today I'm going to share a little bit about what I did at Rototuna Senior High. A little bit of background to the school. The senior high opened in the north of Hamilton 3 years ago, and it was opened with the intention of being an innovative modern school. We were encouraged to try new things, and the whole school is open plan. I'm just going to show you a photo of exactly. Now, hopefully you can have it. You can see that. That's a picture of what the school looks like. The layout, open plan. There are 2 levels to this school. Both levels very similar, and all of the learning takes place in these open plan areas. There are breakout spaces. You can see one right in the middle there. All the breakout spaces are double glazed. The learning that took place in the school were in integrated modules, and the classes were roughly 20 to 50 students each. Each module has 2 teachers, and the timetable was split into 90-minute modules, okay? And then the process to actually determine which subjects would be integrated together was quite involved, and it took a lot of things into account, like the teacher's background. It took into account the fact that maths and English were not to be partnered up, because that would make the module too big with students, because maths and English were compulsory. The students had to have a module which had maths or English in. What I want to attempt to show you, if I can, is a video that took place November 2016, when we were initially doing what we call speed dating. That is, all the teachers would spend 5 minutes talking to a teacher from another subject and just bouncing ideas as to how those 2 subjects could find a common context within which to actually design and create a module. Now, I don't know if this video is going to work, but I shall try.
And you look at some patterns in there. Just definitely see something. So electricity, we have components like.
So what's happening here is that, like I said, each teacher has in turn 5 minutes to talk about their own subject and how it might connect with the other subject, just completely out of the blue, whatever comes off the top of your head. And then 5 minutes later, they swap around. Then the second part of this is the teachers gathering in a circle. Let's see if I can jump to that. And actually sharing what they felt seemed like strong connections with their subject, with the people they spoke to. Once there was enough of the sharing of which subjects were strong connections, they then formed into groups and attempted to work out who were the best people to actually form an integrated module with. And this was for the first and second semesters of the first year, which is 2017. Each semester is 14 weeks long, so the module was 14 weeks long. So this process that's going on here is really, really important to the success of the whole program. Just show you a little bit more. So what happened there was teachers decided that, okay, I've got a stronger connection with that subject. I want to stand with you. I still have a strong connection with there, but maybe you had to bounce the idea off them where their connection feeling is strong, and how to, the way these groups formed, I guess, was quite organic, to use that term. It seemed quite successful, but remember, the school started with about 20 staff with only year 11s. The following year, the amount of staff you see on the camera there doubled, and then last year up to 100 staff. So we had to change the way this was done each year. Now, I'm going to stop sharing that. So you should be seeing me now. So what I'm going to do now for the rest of this webinar is just share some of the subjects that I created modules with over the 3 years, what worked really well, and also I'm going to look at what's happened now, because this year things have changed due to the lockdown. They had to throw that planning out the window and create something that would work to basically survive for the rest of the year. So there is still some level of integration, but it's changed quite significantly. And so at the end, I'll explain how that has happened, because the system that we had in the first 3 years was not entirely successful all the time. Okay, feel free to fire away any questions you have as we go as well. And I think Rachel will pass them on or interrupt me if there's some good ones. Now, the first one, hopefully everyone can see my little chart up here, real high-tech display, because the first module I'll talk to you about is one that I felt was quite successful. It was chemistry and maths, and it was in our second year, so I had year 11s and year 12s in the same class. We had, I think, 45 students, and we looked at the level 2 algebra external, and we also looked at level 2 chemistry involved with chemical reactivity. With that chemical reactivity, it involved acids and bases. And students needed to become familiar with this formula here for how you actually measure and calculate the pH of a solution. Hopefully everyone can see that. Let me know, just shout out if you can't. Now this, to the average chemistry student, doesn't make a lot of sense from a maths point of view when they first get it introduced. It involves logs, the negative log of the concentration of what's called hydronium ions in a solution, H3O+. And from there we get this scale, the pH scale, which students are a little bit more familiar with, where a concentrated acid has a pH of 1, a concentrated base, pH 14, and neutral, like water, is 7. So acid bases run on that continuum with all the numbers in between. What can take students a while to realize is that that scale is not linear. Acid being 1 actually represents that the concentration of the hydronium ions is 0.1, 0.1, whatever the units are, moles per liter or something. The concentration of the hydronium ions for a concentrated base is 0.0000, 13 zeros there, and a 1. So a huge difference between a base and an acid as far as the actual concentrations go. This lends itself to the students learning about negative powers and logarithms, because it would not make sense for the chemist to describe how strong acids or bases were by using these decimals. So we look at what that looks like in scientific notation or standard form. For some students, this was the first time they were introduced to standard form. But you can see straight away why it is useful. And this is one of the key things I think that level 2 students and year 11s and 12s realize that there is a genuine use for this. So we can describe the acid as 1 times 10 to the minus 1, the base 1 times 10 to the minus 14, as far as concentration. Much easier to do that than this. But then when you look at all of the different values for a pH scale, it's just that power that's important, that changes. And that's why chemists decide, okay, we're only going to use this number to simplify things, to create this pH scale. So what is that number? And from a mathematical point of view, of course, that is the logarithm of the number. In fact, it's the negative log of the hydronium concentration. Hence, you can see the connection as to why we have logs, what is the use, and how are we using them. So there's a lot of concepts there that are in a genuine context that the students need, that helped. And I know from my experience, having taught the level 2 algebra in less contextual way, that there were students that were able to comprehend this idea better by seeing it in the context of the chemistry that they were also learning at the same time. Now, this is just one of the areas that algebra connected well with chemistry at the time. And this would have been presented early in the module, but I knew that there would be a big range of students' abilities in maths and there would be some students I'd have to take aside and would go through the basics of some of the decimals and powers before they fully grasped this. And that was fine. We had to do that all the time with big numbers anyway. So that I felt was a nice connection there. Now another one I'd like to show with the chemistry, and I'll just have to share my screen again and see if I can find that. Thank you. So what happened with this module is I found that it was a little bit too ambitious. There were probably half the students that caught on with the level 2 algebra as we were going through the module. We felt that having all of the students do the level 2 external was probably not realistic. So I had to then decide, well, what else could we offer at level 2 maths that would make it a bit more achievable for more students. So we had the sequences and series standard, and we connected this with some of the chemistry we were doing as part of the module. So I created this task, very similar task to sequences and series tasks that we've seen in the past, but entirely within the context of chemistry, as well as something that I felt that the students would identify with. And this is difficult. Sometimes it works and sometimes it doesn't. I think here it worked reasonably well. We're talking about alcohol consumption for teenagers and the effect on driving, as well as medication. So we have this nice pattern here with the different types of alcohols. They produce some nice linear patterns there. I'm going to go really quickly through it. The second part of the task involved how the body processes alcohol, which is a non-linear scale. And I've said here, the concentration of alcohol in the blood decreases by 0.015 milligrams every hour. I had to do obviously a reasonable amount of research here, and it's relatively realistic and accurate. I have simplified things though. Also, we're talking about allergy medication, decreasing in the body by 15% every hour. And then the story goes, we've got these two people. We've got George and Fred. George has had a certain amount of alcohol in the evening, and Fred has had to take his allergy medication at one point in the meeting. And by looking at the sequence that plays out over time, there's obviously laws in New Zealand about how much alcohol in the blood you can have before you can drive. And there was restrictions in Fred's allergy medication as well. So the students had to work out the narrow window of opportunity that would make it legal for them to drive home after a particular time, like 4 a.m. They had to drive 100 kilometers. So I think the students could connect with this, and I felt that that was a nice connection between the two subjects. In this case, the assessment is purely for the maths standard. It's not a combined assessment. There were occasions, I think I've got an example, of an assessment which actually assesses both subjects at the same time, which we were encouraged to do by NZQA to try to cut down the amount of assessment and combine them. So I shall just stop sharing the screen for a moment and start looking at some of that. So the next module, I'd like to just show you something completely different. And that's a module I did just last year, and it was combining maths with music. This had been a bit of a dream module for me for some time now, because I do have a bit of a music background. So I'll show you the assessment evidence document, if I can bring that up. Okay, now you should see in front of you what the module is called intermodulator. And this is the assessment evidence. So this document, there's evidence in this document that contributes to both standards. Now the standards we were looking at for the music, we were looking at level 1 and level 2 composition standard, where the students had to create 2 pieces of music, and depending on how well they did that as to whether they achieved level 1 or level 2. For the maths, we're looking at the simulations for this. And so the idea I had, and this took a fair bit of planning over the summer holiday, where the students used a mathematical tool in order to try to create a piece of music. So I'll just show you what it says there, how we did this. They had to choose a simple piece of music that they liked. And this student here chose Mary Had a Little Lamb. They've analyzed the notes relative to the scale. So they found 26 notes in Mary Had a Little Lamb in the melody. They've looked as to which notes of the scale these are. And you'll see in the pink box there, that's a music software called Soundtrap. And here are the ratios of each note. There's only 4 notes in Mary Had a Little Lamb. So you can see 10 out of the 26 are E's, 10 out of 26 are D, 4 out of 26 are C, and so on. So what they then did is they simulated those ratios in order to create a new piece of music. A new piece of music that has the same ratios of the notes that Mary Had a Little Lamb has. And that's an idea I came up with. I didn't know if it would work, but it was a starting point for using maths just to create a melody. The students then had to, once they've created that melody, it's fairly random, had to decide, does it sound good? Does it sound like a melody? And then they had to learn, of course, what does make a melody sound good. Now, after doing that, they then ran a simulation to answer the question. I'll just find it down here. There in the middle of the sheet there, what is the ratio, what is the probability basically that a randomly generated melody will sound good? And they had to look at the big picture of that question. They had to then run some trials to repeat the process I explained before, to just see how many times it took them to create a melody that actually they believed sounded good. Very subjective, but that was part of the whole analysis of the project, if you like. And that basically was it. Some students went a little bit further. When I was doing the research for a maths and music module, it was clear that there was just so much involved and I had to narrow it down. But we did briefly look at and mention the fact that you could bring in geometric transformations into this, because if you have a look here, this student did this on Soundtrap in the green box there. They've got notes playing. Each dash represents a different note playing for a certain amount of time. And at this point, the notes were reflected. And then the student listened to that to see, did that create an interesting sound? And below, they've been translated downwards. So there was only 1 or 2 students in the class that got to that stage and played around with that because they had time. But that could be a whole module in itself using geometric transformations with music. Now, if I can just quickly attempt to show you a video of some of the music that they actually came up with. So you can see the melody does sound reasonably random, but the music teacher then was able to offer ideas for how to make it sound more musical, more interesting. Some of them worked really well. And some students who had a bit more of a music background were able to produce some really great stuff. Some students struggled with it, and that was fine. They produced only something simple. But again, I think students really appreciated the fact that they could see a genuine connection for how maths could be used to answer some of their questions and to, in fact, create some music. The teacher and I learned a lot about the module as we went. And if we did it a second time, we would change a lot of things. It was the first time we had done it, but huge potential there. Right, now I'm going to have, how's our time looking? 25 past. I'll mention a couple of other modules. I did a enjoyable one where we connected with PE and we looked at experiments, the level 2 experiments standard, and the PE, they looked at training plans. And I have a background in rock climbing, so we used the context of rock climbing to meet both of those standards. The students had to test themselves physically in skills related to rock climbing at the beginning of the module. They then had to plan and carry out a training plan for 6 weeks, test themselves again, and then write up the whole study basically from a statistical point of view to see if they were able to come up with a conclusion as to whether the training plan helped them improve. That's very briefly how that one worked. I'll look at another one where I connected with food technology, and this involved questionnaires, the level 2 standard, as well as with the food technology, they were looking at the manufacturing process. Now I'll just bring up, we did another chemistry and maths module that involved geometry. It involved coordinate geometry, and the context for that module was forensic science. So in the standard, it was a typical, in a way, coordinate geometry task, but it was within the context of forensic science, where they were given 2 stories and a map of Garden Place with a grid, and there were 2 stories from 2 different suspects, and using coordinate geometry, they had to work out who was telling the best story in order to determine who was the actual murderer in that case. I also did one involving physics, linear algebra. It was called Crash Test Dummies. That was the context, is testing moving, rolling cars basically to see if there was a means to make them safer, and involved linear algebra. Now, I'm just going to pause for a moment, because if there are any questions that have arisen, Rachel can pass them on, because at the end I do want to talk about the changes and what brought about these changes. So anything, Rachel, that...
Yes.
So, are you going to do them, Rachel?
Oh yeah, you do them, Pip. Go on.
Okay. I'll just put my video back. So there's been 3 different sets of questions. So the first one relates to the music video, Andrew, or the music example. So there's about 3 or 4 questions. So how did you mark it at the end? Did you mark it with a music teacher or marked it separately to generate grades? Did the students have the same grades for music and maths, or a different one, meaning having a different marking schedule?
Yeah, these questions, the same questions that have arisen in previous webinars. The music teacher and I obviously work very closely together all the time. So we read through the evidence together so that he and I had a clear understanding of, where the student is at from a big picture point of view. But they're very much marked separately. So there's aspects of what was written in that document which definitely contribute to the maths standard, and there's aspects that contribute to the music. It is quite possible, and it did happen, I think, that the student did not achieve the composition, but did achieve the maths. And that was typical of any of the combined assessments that we did. As well as talking with the music teacher, though, both of us had to meet with other colleagues. I had to talk with the other maths teachers as well and get their opinion and explain it all. That was part of our curriculum meetings, is to talk about our modules and how we're assessing them, and get, lots of second opinions basically on how we were doing that, because it was quite new for all of us to do it that way. Does that cover all those questions? I'm trying to think.
The person who asked can probably come back if they did. So a second question was, once you've finished a module with a subject, do you switch to a different subject, or do students have the same combination of classes for the whole time, i.e. maths and music for the whole year? So do you have a bunch of assessments for maths and music to last the year?
I see. No, actually the students will have chosen a different subject for their second module. At any one time, a student was doing 3 integrated modules. When they chose that, there was quite a involved checklist. They had to have one maths module, one English module, and for the other subjects in the modules they'd chosen, there had to be at least 5 different subject areas. Now that was the case for the first semester, for the first half of the year. Then the students choose completely different modules with different subjects, and the same situation in the second lot of modules. The students had to have one maths and one English, and a spread of 5 subjects. But it couldn't just be any of these 5 subjects throughout the year. One of the key aspects to the school is the strong advisory curriculum. And they had an advisor where they worked closely with, who would see what is their overall plan for the year and beyond, and making sure that they were getting the right results, basically, and also that the standards that they entered into were contributing to their pathway, so that they'd have enough credits in certain subjects that they were wanting to follow up the following year. Okay, if that makes sense. That was one of the keys to the success of the integrated program, was the fact that it had to be tracked very closely all the way along. And we learned from various mistakes in the first year and kept improving that to make sure the students, their parents, and the advisor knew early enough in the module, if this student was struggling here, they're not going to get those credits, and we need to do something to make sure they're going to be on the right pathway for what they wanted the following year. So hopefully that answers that question. Yeah.
I was going to say, there's a related question. So how does that work with the timetable, and then the other person can come in?
With the timetable, not very easily. I haven't got an example to bring up at the moment. I could easily send that out, but the timetable, there are 3 blocks per day, 3 90-minute blocks per day. Each module that a student was in had 3 blocks per week. So it could be a block on Monday, a block on Tuesday, and a block on Friday for one particular module. And then there were 3 blocks for another module, and the third module had 3 blocks as well. If that makes sense. So there were 6 blocks per week of academic learning in these integrated modules. How the senior management managed to juggle at the beginning to try to make the timetable work is amazing. It took a lot of work, a lot of time. The curriculum leaders and the senior management had to work to try to juggle the timetable, and that sometimes meant that some modules had to change because a teacher needed, a different number of hours of teaching compared to another, depending on responsibilities and so on. So it took a lot of work in juggling the timetable. Yeah.
So Andrew, I would assume that if people wanted more detailed conversation with you, they could contact you directly if there's a couple of comments coming up about where we're going to that, or we might, and we'd like to know more. So there was another question. What sort of mistakes did you make?
Okay. One of the hardest things, of course, is that teachers are arriving in the school. It's a new school, so they're coming almost entirely from traditional schools and therefore had no experience about it. So one of the biggest things I think which was difficult was working so closely with colleagues, other teachers, because you're co-teaching all the time. There's always 2 teachers in any class, and it's usually, well, always, it's the teacher from the other subject. So we, at the beginning of the school, we had to do a reasonable amount of professional development on how to have good collaboration with staff, with teachers. How we had to be very upfront and learn to be honest about saying, well, actually, we're not meeting enough. We need to find some more time to have a meeting so we can nut this out properly. Some teachers fell into the trap of doing some of their planning during the module, while like getting students to do a task on their own while the teachers sat down and tried to plan the next lesson because they hadn't found time outside of the class to actually plan effectively. So you can imagine there's a lot of differences in the school compared with a traditional school where you've got your own classroom, you've got your own class, and you're doing your own planning when it fits you, which you can't do when you're attempting to collaborate to that extent. So that was one area that a lot of people found difficult and made mistakes, I guess. But that was okay, that was to be expected. We were encouraged to make mistakes. It's part of the learning process, it's part of innovation, and we can't try new things unless we're more comfortable about those sorts of mistakes. I just see if I can think of any off the top of my head. When I mentioned the maths and algebra one, I could tell early in that module that I was a bit ambitious, expecting all of these students to be able to handle that level of algebra. So you could call that a mistake. So I had to adjust things. We had to change, often midway through the module, once we got a feel for the students we had and how they were handling the subject and what their needs were. Like if they really needed those maths credits and it's clear that half the class aren't going to get it, well, what can I do halfway through, 7 weeks in, to help them get some maths qualification, if you like. Yeah.
Andrew, are you happy for me to put your email address in the chat line? Someone's asked for it.
Yeah, definitely. Yeah, I'm very keen, always was keen to hear from anyone who is attempting to try these types of things. And I know a lot of schools are now, not necessarily under pressure, but having a go at integrating. And so, yeah, definitely, I'm really keen to share not just what I've done at the school, but other teachers. We've done webinars as well about it, the pitfalls and so on. And I will tell you that the school has now changed. One of the advantages of the school is that it is flexible and open enough to actually try something new again. They've done that this year. They've actually ditched the integrated modules in favour of what they call wānanga ako, which are schools of learning, more like thematic groups composed of several subject teachers, and then the students attempt to find their own ways that subject integrate. Because that, I guess, is one mistake we made, was that the students found it a little bit contrived because it was the teacher who had come up, the teachers had come up with the 2 subjects that would integrate, and the students weren't involved with the planning. And originally we had the dream of wanting the students to be part of it. So the school has now changed to try to move in that direction. Yeah, but yeah, absolutely. I'd like to hear from everybody who is trying these sorts of things. The more we do connect in this way, and share, we cut down each other's work, and it's really good to hear the other new ideas that people are trying.
Cool. I have another question that came up. Do you have any concerns with the contextual assessments that you made being appropriate for the curriculum level, i.e. satisfying external moderation?
Yeah, absolutely. But in much the same way that I have concerns about any assessment that I'm using, even if it's just a maths assessment, I'm also concerned about that and its appropriateness for assessing the students and giving valuable information and giving the student valuable learning, as well as meeting the standards. So that's always the case anyway. But when trying so many new things, like every teacher that's at Rototuna had to create their own assessment tasks, no matter how experienced they were. So we had to set aside a lot of time as a curriculum area to sit down and share and even go beyond the school with experts and say, is this assessment task meeting the standard, and are we doing enough to provide for, achieve merit and excellence? The usual questions. So yes, there always is concern about that. We did want to be, it puts a lot of pressure because that requires a lot of work. So at some point, it was a dream to try to make this all work in every area all the time. So we worked closely with NZQA as well, and they wanted to come and see what we were doing, particularly in that first year. And so we met with them often, and they were open to us sending in tasks and getting advice and say, is this suitable? Is this working? Do you think it's going to work? And so on. But yep, good question.
Okay, there is another one about somebody who was trying to combine stereochemistry and visualization and transformations, but found it challenging to implement and would like to seek advice on this. I suspect that may be a nice one for them to connect directly with you on.
Yeah, definitely.
Yeah.
And when I spoke with the chemistry teacher when we were coming up with ideas, we looked at that as well. There's a huge potential for geometry in chemistry.
Yeah.
Yeah, not simple.
And I've got somebody else who's had a student pull a computer keyboard to pieces and reprogram it to make a gaming console. She designed the housing for it, including painting it and cutting out circles for buttons, and ended up with measurement, design tech, and digital tech. So sounds like there's quite a good crowd of you out there doing some really amazing, innovative stuff in terms of integration. So I'm going to pause the questioning there. I'm pretty sure that Andrew will happily take questions directly from people at a later date, and I'll hand back to Andrew and Rachel.
Yep, definitely. And good on you people who are trying these new things, because maths deserves it. Maths is such a good subject and is out there in everything, and it deserves us putting in a bit of effort to actually show students how amazing it is and how it connects and how important it is. Yeah, so thanks very much for that. The Waikato and Bay of Plenty Maths Association are having a online webinar, online conference at the end of the year, 23rd of November. We are likely to do some more integrated sessions then as well. So yeah, let me know.
Yeah, so that's great. Hopefully everyone is enjoying these online PD for the sort of additional flexibility that it gives you. There's just one. Yeah, okay. So just getting lots of thanks, Andrew, for a very interesting session. And I think, as you say, with everybody supporting each other in this area, you can have achieved quite a lot. And as long as we support each other, it doesn't make the workload too much. So I think that's great. Yeah, some more people saying thank you very much.
Great. Yep.
So there is, this session has been recorded, so if you do want to go back and see it again, it will be appearing on the AMA website. So yes, we've got another AMA online session on Saturday, November the 7th, so just a few dates for your diary. And Andrew mentioned the Bay of Plenty one on the 23rd of November, so that's great. And then we've got Stats Day and Calc Day on the 30th of November and the 1st of December. At the moment, they're being planned for in-person events, but we will actually have the fallback position of going online if the situation demands it. So we're quite prepared for that to be online if it has to be. There's also going to be a level 3-4 fractions, so just keep track on the AMA website of when that date will be confirmed. So these online PD is still quite new for us, and so we really appreciate your feedback on these online events, whether they are serving a really good purpose and whether they're actually proving, maybe even more useful than the in-person ones used to be. So I would really encourage you to fill in that feedback. And also it gives us an idea of what sessions that might be useful in the future. So if there's something that you think we haven't covered at all, just let us know and we'll seek out someone who can present that next time. And just as I said, all the sessions today have been recorded, and so you can, as you've registered for these events, you can go back and watch them again. And we hope and really encourage that people who have registered who weren't able to join us live will watch the recordings. And we hope you've enjoyed this event, and we'll see you at another event soon. There's some good sessions coming up at midday. Anna Ferguson is talking about teaching statistics. There's Jodie Hunter talking about making connections, and Megan Clune is talking about 3-act maths using in the online space. So do feel free to leave the meeting now if you wish and join those other sessions at midday.